How's it going, everybody? Welcome back to the MPLS Layer 3 VPN section, and let's dive into our next topic, which is VRFs. Now, what is a VRF? A VRF is a virtual routing and forwarding table. Never heard of it? I'm sorry. So a VRF allows you to create routing tables that are not in the global routing table. Huh? Okay, so basically the idea is if you want to separate traffic from the global routing table, which is known as the default VRF, you need to create your own VRFs. So that's going to create another unique routing table for customer A, customer B, customer C, or any other type of traffic you want to put into it. If you want to take traffic out of the global routing table and place it into its own unique VRF or its own unique routing table to do traffic separation, the VRF is how you would do that. Think of a VRF to layer 3 forwarding as a VLAN is to layer 2 forwarding. So you might be like, well, I can put an IP address on a VLAN. Yes, you can. But a VLAN is layer 2 traffic. A VRF is layer 3. Keep that in mind. So the idea now that we're going to be taking a look at is understanding what a VRF is actually going to be being done in the layer 3 VPN process. Well, the capability is actually pretty straightforward, right? We create the VRF, we do some wizardry to it, and then things just magically work, right? Not 100%, not quite exactly that way. But so to put it into easy to understand terms, let's go ahead and understand what it's trying to accomplish. So we need to first understand two separate things. Let me go ahead and bust out my pen tool for this because I like to whiteboard. So there we are. So the VRF itself is going to be made up of two specific capabilities. The first one is going to be what they call the route target value. I like to lead off with the route target value because it in itself is specific to the VRF itself. The other one is going to be the route distinguisher, and we'll get to that in just a minute. The route target value determines what routes or what routes can leave the VRF or can be added to the VRF. So we have the concept of the import policy and the export policy. Now, the difference between these two is import is you're taking routes from IBGP, VPN, v4, and sending them into the VRF. Okay? With the export, you're taking routes from the VRF and you're sending them to IBGP, VPN, v4, and propagating them across to other provider edge routers. Now, in most cases, I've seen most instructors that I've followed for a long time use the route target policy capability of both, and then they use like a 1:1. Well, that'll work, right? But it's kind of lazy. But it's easy to understand because if I take route target both 1:1 on this guy and this guy and this guy and, well, this guy actually won't work, and this guy, and I have the route target import export policy is the same. We'll say 1:1 here. If I do that configuration across all of the provider edge routers, guess what's going to end up happening? All the provider edge routers are going to send and receive routes for that particular customer. So it makes it easy to understand. I normally will liken a route target policy to an ACL or an access control list. Because with the route target policy, you actually have to go in there and whitelist or specifically permit specific traffic to be received or to leave the VRF itself, where there is no, and then you have a deny all. There are ways around that where you can say, you know what, I don't care what the VRF information is. I want to receive it anyway. You can do this through just turning off the filter process. So I just want to receive all the VRF information from every VRF. You can turn on route reflectors, a bunch of other stuff. We'll talk about those details later on once we get through static routing and we're into some of the more advanced features and capabilities, and we're trying to provide scalability and things like that. But for right now, out of scope. Trying to keep things simple for right now. But what we want to understand is we need to be able to do something on the configuration in order to make it for traffic from R13 to be received in by CSR1 and then be sent across through a VPN v4 update to our CSR6, and so that CSR6 can then take that route inbound and then propagate it down to R15. Now, when we talk about the flow from left to right, like we are currently, well, I should say from right to left, in this particular case here, we need to export here and import here. If that makes sense, we're exporting traffic out of the VRF and CSR1 into the IBGP peering up here. This line drawn between CSR1 and CSR6 is the IBGP peering, and we need to import whatever VRF or whatever traffic that we want to receive from CSR1 into CSR6. Now, if we don't have that policy in place, or it's incorrect or something like that, we can do a debug via BGP, and we'll actually see the configuration, the incoming route targets get dropped because we don't have the extended community value that is the route target value isn't defined. In other words, we're dropping the traffic based off of a deny, or denying the traffic to be added. So there are ways around that, which we'll talk about later on, like I mentioned. So what we want to do is we can do one of a couple things. We can do the route dash target both 1:1, for example, for customer 1. This is normally what most instructors are going to show you, especially if you're just getting into MPLS Layer 3 VPN with the VRF and trying to understand what the route target policy is. I am not going to do that. What I'm going to do instead is I'm going to make it a little bit more unique. So we have an autonomous system number of 100. We have specific interfaces that can be configured for different capabilities. So what I'm going to do is I'm going to have a customer 1, right? We already have customer 1 set up. It's all these routers turned on, 13, 14, and 15. So I'm going to create a customer 1 and a customer 2. What I want to be able to do is I want to be able to go through and I want to be able to control what routes leave and what routes are learned. Well, in order to do that, I need to have a route target export import policy that allows me to do that. So what I would normally do is I would have for customer 1, for example, let me just start off with this. For customer 1, I would do a route target import, or I would always export. I always start off with the export first. So export, let me export a specific route target value. So I'm going to say, in this case here, it's going to be, I'll say 100:1. So I'm in autonomous system 100, and I want to export traffic for customer 1 routes. And then I would have another entry below that. I would do a route target import. And then I need to match other devices. So I could match on 100:1. I could match on other attributes. The way that you would do this is you're going to have two different ways of doing this. You're going to have the autonomous system number, and then some other value, like 1, for example. This is one option. The other one would be doing it per PE router. So, for instance, CSR1 has the loopback address of 1.1.1.1, and I could do just do this one, here, 100. That's an option. And I can do that across the board. And that's how I normally will do this. I will go across the board and I will do it on a per device basis. I will have its own, I will import and export based off of the loopback address and the autonomous system number. So that gives me a lot of flexibility and a lot of scale. So there's that option. How you choose it is up to you and how you want to go about doing that. So let's go ahead and take a look at exactly how this looks real quick before we get any further on down the conceptual train. So we want to start on CSR1. I'm going to go ahead and I'm going to go to global config. I'm going to create a VRF. So I have two different ways of doing this. I can do IP VRF and then the name, but I don't want to do that. Because if I just type in IP VRF, this is IP IPv4 only. Okay, we definitely don't want that. We want, if we want to support IPv6, we need to type in VRF and then the option of definition, and then the name. I'm going to type in here, this is going to be C1. Now underneath here I have quite a few options. I'm not going to go through all of them initially, but the first one I'm going to specify here is going to be the route target value. The route target value here, I have the both command, right? I could type in both and, you know, go from there. Or I could do the import, or I could do the export. And you can see that it's got a format. ASN:NN or IP address:NN. I'm going to choose to do 1.1.1.1:100 or 1, for example. I'm going to type in route target export. I'm going to type in 1.1.1.1:1. Now by doing that and having :1, I can, it says VRF C1 does not have an RD configured. Okay, so let me pause just a moment and talk about what the route distinguisher is doing. So in the example that most customers that I've worked with have always ran some variation of the 10net, so 10/8 addressing. Well, if I have, let's say I have 10 customers that all peer via BGP to the same provider edge router. Now let's just pick on CSR32 because it's got multiple peerings to it. Well, if I have 10 customers, all individual customers, peering to the same provider edge router, but the same addressing scheme, I need some way to make sure that customer A traffic is separate or logically different from customer B traffic. How do I go about doing that? With the route distinguisher. The route distinguisher value is placed in front of any routes that are learned from the customer. So basically what it would look like is a 1:1 and a value after that. So that would be the subnet. So 10.1.1.0/24 or 192.168.37.0/24 or whatever the case might be. So when I go to configure this, I would type in RD and I could come up with some value. I'm going to come up here with 100:1 so that the route distinguisher value looks a little bit different than what the route target value looks like. As we look at here, we can use the same basic structure or nomenclature that we can for the route target value. So I can type in here 100:1, and then I can come up here and do this, and then I can do I can say import, and I want to import, in this particular case, I want to import 6. I want to import, whoops, I was supposed to say type in import 6. I can import 32, and I can import 9. Now if I do show run VRF, you can see by looking at this that I have a route distinguisher value of 100:1. So that means that any routes that CSR1 learns from R13 are going to be prepended with 100:1, and then it's going to show up with the prefix. The prefix will show up in the very beginning here like this. I will literally show you what this looks like. It'll be a colon and then 10.1.1.0/24. So the route distinguisher value will always be in front of the prefix itself. And then since we have VRF C1, we're going to take this particular route here and we're going to send it out to CSR6, CSR32, and XRV9. These 3 nodes will receive this route because we're saying I want you to send traffic. So this goes to this guy goes to this guy, and this guy goes to this guy. We haven't configured them yet, but that's going to be basically what we accomplish. So we have that. So then I can scale this out as big as I want. I can have hundreds of customers because when I go back to the console here and I type in, let me do this. If I do the, let me go ahead and clear the screen off real quick. Clear. If I show run, if I do a route target import, import value of 1.1.1.1, or let's just throw some number out there, 21, colon, why is that not? Route target import 1.1.1.1 colon unrecognized command. There really is no upper limit. So technically speaking, it's 32 bits. So the route target value and the route distinguisher value are two 32-bit numbers. So that means that the first half of this number right here, this guy right here, that is 32 bits. And this is a 32-bit number. So when I configure this, this is also a 32-bit number, and this is also a 32-bit number. So that means you can have the, for example, specific to the route distinguisher, this and this right here would equal 64 bits, plus you do another colon after the 1, and then you add the IP address, which is going to be another 32-bit value. So that means that the entire address for a particular prefix that's been, or I should say the entire bit length for a particular route learned from a customer could be up to 96 bits long. And by doing that, it makes the route unique globally inside of the route, inside of the provider edge. Same thing applies here for the route target export. So this means I could have, in this particular portion here, I'm saying customer 1, and I'm saying customer 1 here. I'm saying I'm going to export traffic from CSR1 via colon 1 for customer 1. But if I wanted to, I could have, technically speaking, 4.2 billion customers configured. Obviously, the memory on the router would run out long before that would ever happen, but numerically, it's possible from a numbers perspective, and that's it. It actually wouldn't work it wouldn't technically work in the real world. So I just wanted to make sure that you guys understood that. So we have that. So that's basically how this comes into play. So now I've created the VRF on CSR1. Let me go ahead and do show run VRF just to verify that. Good. That's all squared away. So now I can literally take this command structure and I can run over to CSR6, CSR32 and configure them. So let me go ahead and just drag this config. Actually, let me just grab these first few here. Grab these two and go to CSR6. We go ahead and configure these two, and I'm actually going to say route target import. That's correct. Let me hit the up arrow, and I'm going to type in no route target export or import of that. I'm going to say this is actually route target export that, and then route target here will be route target import, and no route target this guy. So do show run VRF. So now I should have a route target. I should be exporting routes from CSR6 and importing from 1 and 32. And I'm just going to come up here and I'll type in 9 just for the sake of argument. So I'll be taking that. So that takes care of that. And so now I need to go over and do the same thing for CSR32. Get him configured. So I will say that's fine. Import that. Import that. I'm going to come in here and type in no this. Pull this out. And I'm going to say route target import 1.1.1.6. But for this one right here, I'm going to know this one. I'm going to switch this to be an export value and do this. So do show run VRF. So you should have, the export should always be the local device. And then you should have as many import route target values as you need to receive traffic from other devices. So we have all of that. So now let's go over to XR9 and configure him. So let's go to log in, go to global config and type in VRF. There is no definition here, so you just name it C1, and underneath here we go and we configure the address family IPv4 unicast, and under here is where we define our export and import policies. We're going to type in, we'll say export first, export route target value, and then I will specify that I'm going to export 1.1.1.9:1, and I'm going to say import. I'll type in 1, 6, and then 32. So show config, that'll be my syntax. Pretty straightforward stuff, and that's going to be pretty much the extent of what I need to do. Now there's other options that I have available to me. I can go, you probably noticed this one right here when I was typing in address family IPv4 unicast and typing in the import rule where I had this route policy option or from another VRF. Basically, this gives me the ability of creating a route policy to call other route target values. Instead of manually configuring them here on this line, I can go and create them, call them from a route policy to make it more modular. And then I can go call other route target values. So that's one option. This is more commonly seen when we talk about doing filtering and things like that. We want to add some hierarchy to the filtering process and stuff like that. So, but I'm not going to really dive too much more into that. Now, the very last step to this process, which I am not going to do in this video, is I'm going to go and I'm going to configure, when I go to do the BGP PE to CE routing, I'm going to go and do the attach the VRF config to the interfaces then, because I just wanted to focus on the VRF setup in this video. If we do a show config, I don't think I've committed it yet. I'll go ahead and commit it before it times out. So that's going to be how that comes into play. Oh, there's one other thing that I need to talk about real quick before I go any further. Notice that I did not specify the route distinguisher information underneath the VRF. That is actually done in BGP underneath the VRF itself. So where in iOS, we went and we configured the route distinguisher underneath the VRF right here. We do not do that in XR. We actually have to go underneath the VRF configuration in BGP in order for it to be done there. And then once that's been applied, then we go ahead and do the rest of the configuration from there. So I'll show you how that goes in an upcoming video. We're actually going to go in the next couple of videos. It's going to be a lot of VPN v4 focused stuff, so we can get all the peering set up and stuff like that, so that we can then focus on the PE to CE routing, because we only have one major step left. We're going to first do the full mesh configuration, and then I'm going to basically consolidate it down a little bit and focus on just doing route reflection. So route reflection is going to give us more flexibility down the road to do other things like add path and best externals down the road that we'll be taking a look at later on. So until next time, guys, thank you so much for stopping by. And until next time, guys, take it easy.